So this one is an accumulation phase. Because we're putting money in to reach a goal. But here, instead of being told what our monthly payment is, we're told what the lump sum is we want to have at the end. We're told the future value. So to figure out our payment from that future value, it is equal to the future value divided by, remember, 3 parentheses. So I'm actually going to put in the number there, the 400,000. 1 plus, what goes in next? 0.08. Then the next number depends on our periods in a year. What's it going to be here? 12. How do we know it's 12? Put away each month. Very good. Close the parentheses to the power of 12 times 30. Good. I'm going to actually cross that off and put in 360. Then what? Minus 1. .08 divided by 12. Close and close. So let's see if I get the same thing you guys do. Divided by 1, 2, 3. $268.39. $268.39. Any questions? Okay. So the other side of it was, what if we knew the payment? So let's say Stacy saves $400 each month at 7% interest. How much will Stacy have in 25 years? Figure that one out for me. So this one, we're looking for the future value. We have the payment of $400. That's going to be times 1, 2, 3 parentheses. 1 plus 0.07 divided by 12, because it is monthly again, to the power of 12 times 25, which is 300, minus 1, and then which gives us $324,028.68. How many of you came up with that one? Okay, we're doing well, it looks like. Oh, we're missing like half the room here tonight, aren't we? Wow. So that is the accumulation phase. So this one up here is if you know the future amount that's a lump sum and want the necessary payment. So you know how much you want to have in the future, and you need to know how much do I need to pay to get there. This one, you know the payment You're trying to find that future amount, that lump sum you're going to have in the future. And the key is both of these you are paying in. Hence the accumulation phase. Liquidation phase is a little bit more of a complex formula. Now remember, there's also that annuity due. At the end of the class, if there's time, we'll come back and we'll look at annuity due so you can see that extra little factor we have to multiply by. For drawing money out, that is the liquidation phase. And when I say drawing out, that's technically correct like 98% of the time. There are other applications of liquidation phase where you're actually paying money in against the total, but I'll go over those here in a bit. Anyway, anytime you're in the liquidation phase, you are starting with a lump sum. And you're dividing it out to be paid out in payments. The reason I say that 98% of the time you're drawing money out is because the same math, the same formula applies to taking out a car loan or a home mortgage and calculating what the payment is you have to pay into that mortgage to pay it off. But technically, really, that's money that they've given you and you owe it back to them and you're paying it back. So technically, you are drawing down that lump sum. It just looks different because you're giving the money to them instead of them giving the money to you. So the formula changes slightly. We have a present value, not a future value, because we're starting with the lump sum. The amount of the payment we can get, or the amount of the present value we're going to have or we need, is equal to the payment times 1, 2, 3. This first part will look familiar. 1 plus our rate divided by n to the power of n times t minus 1, close parentheses. That part should look really familiar. This part will start to look familiar as well. Power of r divided by n. However, there's an extra factor in here. Times, parentheses, 1 plus r divided by n to the power of nt again. Close and close. If you want to draw out, let's say $1,000 a month, for 20 years. So you figure in retirement you're going to live for 20 years and you're going to need to pull out $1,000 a month. At 4% interest. During the liquidation phase, when you're drawing, if it's a retirement account and you're drawing money out, generally you're going to earn lower interest because you don't want to take as high of a risk. As you're paying in, you'll take a little bit higher risk, get a little better interest rate, because you can always just keep working longer if something goes wrong. But once you retire, you really don't want to have to go back to work if something goes wrong with your investment. So you're going to usually get a lower rate, but generally you're going to go with a guaranteed rate or a nearly guaranteed rate, a very, very low risk rate. So there's very little chance of you losing money. That way you know you don't have to go back to work at least. So if you want to draw out $1,000 a month for 20 years at 4% interest, how much do you need to start with? So I'm saying, what is that present value? What is that lump sum that I need in the bank right now? That if I'm earning 4% interest on it, I can draw out $1,000 a month for the next 20 years. So my payment is 1,000 times 1, 2, 3. What's going to go in here? Yep, 0.04. Yep, because it is $1,000 per month. Parentheses. Power of 12 times 20 says 240. Minus 1. Parentheses. Divide by. Parentheses, then what? 104 divided by 12. Times another parentheses. 1 plus 0.04 divided by 12. Close parentheses. Power 240 again. And close and close. Now, those of you that have a one-line display calculator, I'm looking at it looks like everybody here has a two-line display. Those of you, if you do happen to have a one-line display calculator, it will not do this formula. It has a character limit. Somewhere around right here, it just won't accept the characters anymore. So it clogs up its memory and it'll give you an error. So let's do this. 1,000 times 1, 2, 3. 1 plus 0.04 divided by 12. Close power 240. Minus 1. Close. Divide. Open. 0.04 divided by 12 times. Close. 1 plus 0.04 divided by 12, close, power, 240 again, close and close. $165,021.86. So you think about that, $1,000 a year for 20 years. $165,000 isn't that much to have to start out with. That's not a bad return. If you think about that, $1,000 a month times 12 months in a year times 20 years. How much are you really drawing out? That's $240,000. So you're doing okay there. Any questions? So I'm going to have you try one on your own. You figure you will need $2,500 a month to live off in retirement. If you retire at 67 and family history indicates, I'm just going to put it bluntly and save some words. You'll die at, 82. How much will you need if you earn 5.2%? Give you a chance to so we have 2,500 times 1, 2, 3, 1 plus 0.052 divided by 12. How many years are they going to live? 15. 12 times 15 is 180 months. Minus 1, close, open, 0.052 divided by 12 times, open, 1 plus 0.052 divided by 12 to the power of 180. Close and close. $312,012.04. How many of you had that? Good deal. You have $500,000 to retire off of. If you I should say expect, but let's say plan to live 25 years. How much can you draw each month at 4.5% interest? Now notice this is not the same type of problem. We're going backwards. We have the lump sum. We know how much we have at the beginning, and we want to know what that payment's going to be. How do you think the formula changes? Yeah, the only thing that changes is it's divide instead of multiply. $25 years is going to be 300 months. I'm just going to put in 300. We get 2779.16. You guys need a minute to make sure you get the same thing? So yeah, it's the same formula, you just divide instead of multiply. So, I'm going to have you guys try one. The answer was $2,779.16.
On the first one, I didn't get that one.
Up here, the 312.
Oh, 312, 12, 04.
Yep.
Okay, that's okay. I just want to make sure I got it right.
Perfect. I'm going to have you guys try this one then. Yeah, screw that. Let's go. Lauren has 120 $100,000 saved. At 6% interest. How much can Lauren draw each year for 12 years? Let me try that one in your notes quick. Howdy. So you start out with 120. You're going to divide by 1, 2, 3. What goes in here? 1 plus 0.06. Divide by 1. Because it's yearly, so it's just once a year. To the power of 1 times 12, or just 12. Minus 1, divided by, parentheses, 0.06, divided by 1 again, times, all parentheses, 1 plus 0.06 divided by 1, close to the power of 12 again, close and close. Now you'll notice when I put it in the calculator, I don't put in the divide by 1 because it's not going to do anything. I'm just putting it on here so that it's consistent, that you see that's once a year. But when you type it in the calculator, it's okay to leave it off to save some keystrokes. We get that you can draw out $14,313.24. That's each year for those 12 years. Now, I had mentioned that this is also how they calculate loan payments. I like to use this example just because so many people out there want to have that biggest, best, and baddest truck out there. So let's say you go out there and you buy that $45,000 truck, which isn't even going to be the biggest and baddest. I saw one the other day, I think it was $62,000. Considering I paid $39,000 for my first house. Yeah. So you buy a $40,000 truck. Your interest, now right now you can get some fairly low interest rates, but if we're going to put that, well, let's do 3% for 6 years. Once upon a time, they wouldn't even finance a vehicle for more than 5. But now, actually, I've seen them go up to 8. But we're going to do this actually as 6 years, and we're going to do it as 8 years. It's actually that same formula. We have that lump sum, and we are drawing it out. We're paying it down. What we're doing is, by making our payments to the bank, we're drawing down that total. So this is going to be that $45,000 divided by 1 plus 0.03. Divide by 12, because we do have to make payments every month. 6 times 12 is 72, minus 1. Close, divide by, open. 0.03 divided by 12 times, open, 1 plus 0.03 divided by 12. Close, Power of 72 again. Close and close. Seems like it takes forever to punch these in, doesn't it? And 683.72. $683.72. Now here's what I want to do before we move on. How much do you end up paying for that truck? Take that amount times 72 payments. I'm just going to leave what's in my calculator, which is a little bit smaller, rounded off. $49,227.51. Which isn't terrible because you got 3% interest. So you pay about an extra $4,200 because of the loan. So here's the question. What if you can't afford $683 a month? Probably shouldn't be buying the truck. Exactly. But I've seen them finance these out over as much as 8 years. So that $40,000, unfortunately, for 8 years, they're not going to give you 3%. Who was it? It was somebody who was telling me they just financed a vehicle and it was 6.5%. But that was for a longer period of time. So we're going to go up to 6%. For 8 years. The reason being is if you have to finance it out over 8 years, there's a bigger chance that that vehicle is not going to outlast the loan and that you're going to have to trade it off or do major repairs on it before it's done. The longer the loan is, the bigger the chance that the banks get in the car before they're done with the loan. Put it that way. This will be $45,000 divided by 0.06 divided by 12. 8 years, 8 times 12 is going to be 96 payments. So I'm guessing a lot of you probably already have this, but I'll punch it in so we got something to compare to. $591.36. So there's your monthly payment. Now let's take that times 96 payments. That truck now cost you $56,770.98. By financing it over 8 years instead of 6, it just costs you $7,500 more for that vehicle. Partly because of the longer period of time and partly because of the higher interest rate. Any questions? Okay, so let me do this. You want to have $50,000 in 15 years to send a child to college. at 7% interest. How much do you need to save each month? Okay, now, questions we need to ask. Is this just compound interest? Or is it an annuity? How do we know the difference? Compound interest starts with a lump sum, adds interest to it, and ends up with a lump sum. There's one payment at the front and one amount pulled out at the end. An annuity either has regular payments feeding into a lump sum, or a lump sum being paid back out in regular payments. So does this one involve a lump sum becoming another lump sum? How much you have to save each month? That's implying regular payments, right? Doesn't say how much would you have to put away now. It's how much would you have to save each month. So that is annuity. So we know this is an annuity and not just compound interest. Next, is it accumulation or is it liquidation? Accumulation, we are paying in. Liquidation, we draw out. So is this where we're looking to pay in or are we looking to draw out? Yeah, we're going to save. We're paying in each month. We're accumulating. So this is accumulation phase. So that means we use the shorter formula. Doesn't have that extra little term in it. So 50,000 at 7% for 15 years. 50,000, multiply or divide. That's the amount we're going to have. So we're going to divide by that. That's the lump sum we're looking for the payments. 1 plus 0.07 divided by 12 to the power of 12 times 15 is 180 months. Minus 1, close, divide, open. 0.07 divided by 12. Do I have to put times anything here? No, because we're accumulating. So that's it for our formula. $157.75. How many of you got that? Any questions on how I got that? Okay, let's do one more example to take us up to break here. You can spare $350 a month. How much will you have in 20 years at 11% interest. Is this, it's 11. Now again, compound interest or an annuity? Are there regular payments? Yeah, you're going to spare $350 a month. So that means this is an annuity. Accumulation or liquidation? Accumulation. I'll let you guys pick out the correct formula. I'm going to write it out here as you're going so you can look up if you want to check it out. What'd you come up with? I mean, 302,973. 0.31. Anybody else get the same? No? Yeah? Okay. Do you want me to let you type that in again and see how it comes out? Tell you what, it's time for break anyway. Let's take a break. We'll come back and we'll look at more examples, give you some more chances. And we'll go from there. So let's come back at 6:31.